Thank you for the introduction and good afternoon to everybody. We know that your time is very precious. You're very busy out there, so we appreciate you taking the time to spend it with us to go over air-cooled condenser cleaning and leak detection. It will be a rather quick overview of how to do both practices, but we hope that you're able to gain something from this as we move forward. I think the first question that we always ask, and it goes along with the ACC users group, is that every year we find that there are more and more air-cooled condensers out there. And we take a look and say, why is there an increase in this number? And we come across these four basic reasons. And number one on that list is water issues. We're running into more and more situations where you can't get the water. Plants can't get them. You cannot either get the EPA to approve them, or you can't get the license to get the waters, or you have problems with the pass-through of the water itself. And so you run into a lot of issues. And so water becomes a source where you just can't use it, can't get to it. You also have a plant location. And in more and more situations, we want to locate plants in areas where maybe water is inaccessible. And you just can't get to that source. And so we're looking to another source in order to make the unit run. We run into thermal pollution problems. Once through systems have to be avoided. And in many instances, you have local ordinances, citizens' complaints. They're complaining about a particular unit, and you just cannot put a plant in a local condition or local place that you want to put it. And so we locate these units in areas where the air-cooled condenser comes into play. And a viable option it is. Taking a look at the condenser itself, the air-cooled condenser, I'm sure many of you know this, but I just thought we'd go over it because this plays a role in the cleaning and in the leak detection of this particular unit. A-frame constructions typically with the fin tubes and the fans usually located in the base. For some of you, we have seen some inverted where the fans are at the top. If any of you have one of those, an independent phone call to how to go about doing cleaning would be welcomed, as we can do that also. But there's also an awful lot lengthy and large diameter exhaust piping that goes to this unit. So this is something that we're going to have to consider whenever we go into this process. Air-cooled condensers, what's the advantages? What's the disadvantages? Well, the big advantage is that you can put them anywhere. You don't need the water. But it has some real disadvantages, some things that you've got to remember. And this plays right into the cleaning of the unit. It's got a low thermal conductivity. It's got a low density and a low heat capacity. What's that mean? It means that the transference of heat from the steam over into the air itself is less than the transfer of heat into water. Water is more dense. It's got a higher thermal conductivity. And so you need less of it to cool down the steam. Air-cooled condensers, we need more air. We need that flow. And that flow has to go through those fins, up past those tubes, unimpeded, in order to get the most efficient action and results out of that particular unit. You also run into energy penalties. So right when we're trying to get the units to run at peak capacity in the summer, the air temperature is higher and thus the transfer is less. And so we must make sure that the efficiency of the unit is running extremely well. And the last but not least, there's an exposure to the elements. These large units sit out there in Mother Nature, and they're exposed to the sun, they're exposed to weather conditions, they're exposed to pressure, they're exposed to all the elements, wind, whatever's out there, and how that affects them. So I decided to take a couple pictures here and just show some of these. One on the right-hand side is a relatively small ACC unit. You can see it's got two streets there. You can see the steam headers up top. But just taking a look at one of the small ones, you can see it's still quite large. If you take a look at the one on the left, that's got three streets on it. And you can see the size, how high it is above the ground based upon that truck that's sitting there. Now, one of the most important aspects of this particular picture that I want to point out, and the one on the right really points it out, is that you can imagine everything that's on that ground is now susceptible to being drawn in by those fans and blown up through the fans and up into the fins. So in that instance, you can see there's a lot of dirt there. They try to put some sort of gravel underneath or concrete underneath. That works well. but any type of debris that's laying there can be drawn in, pulled up, sucked into those fans, and blown up into the unit itself. This gives you an idea on this structure right here of how hard it is to get the equipment up to the unit itself. And so we face another strategic issue. How do we get the equipment down on the ground level up to the top? Sometimes a lift. Most instances, we are carrying it up piece by piece to get it up top onto the unit itself. And so there is a challenge, if you will, to get the equipment there and to get the water that we need and any other resources that we need for the unit. So what kind of fouling tendencies does this have as we go into cleaning? You know, air-cooled condensers have the same type issue as steam condensers. It's just it's a different type of fouling. What we run into in many instances here are pollen, dust, leaves, plastic bags, anything that's out on that surface. And if you remember back to that picture that I showed you, you can imagine those fans turning. And anything loose on the ground as it gets closer and closer to those fans gets picked up, pulled into the air, and blown up into the fins themselves. The picture on the top right shows the pollen. Now, anybody that lives in the Northeast like I do knows that every spring we get a lot of this stuff. It's on our cars. As that is floating around in the air, it's also being sucked up and pushed up into these fins, and it is sticking between the fins, thus limiting the amount of airflow that goes through. If you're down in the Southwest, you're going to get a lot of dust. You may not have as much pollen, but you're going to get a lot of dust. It's out there in the desert. It's out in some flatlands or out on ranges. And you're going to get dust. You're going to get some leaves, anything that's going to blow up through there, and it's going to stick to those fins. And if the picture on the bottom right shows what those fins look like once they start to get fouled. Now, in this instance, we have some units that we run into where there's only one row of fins. But in many instances, these ACC units have various levels. They may have 2 or 3 different levels of fins all on top of each other. And so as the fouling begins on the bottom, it gets pushed up into these fins and really becomes encased in there and becomes difficult to get out. And here's a picture of what one can look like when you let it go, or maybe you're just in a situation or an area where this is at the end of your season and this is what you're looking at. If you look at the upper right-hand corner of that picture, you can see that there's some air going through there. You can see the fins. You will get some air. It's going to be restricted some. You can see some of the fouling off on the corners, but you will get air through. But if you take a look toward the center of that picture, especially the center bottom portion, you can see that those fins are completely blocked. And so what's happened here is you've restricted airflow completely. So now what we have is a situation where the air itself is less dense and is not quite as, hasn't got the ability of water to do that heat transfer. And now you're adding an energy penalty in the summer, plus the fact that we have limited how much air can get up through those fins. We've eliminated our surface area. And that is the real key. That's the key to the ACC unit, is surface area. So what happens? Well, in a lot of instances, the plant gets in trouble, can't bring the unit down, got to be pushing forward. So they go out and they get the water hose and they put water onto the fins themselves, which cools it down. And for that instant, it absolutely helps with their condensation. But whatever's in that water now begins to break down and solidify itself to the fins itself. So what happens is you end up with something looking like this, where you have a heavier fouling now on the tubes themselves that you've got to get off and remove if you want any kind of efficiency in your unit at all. Many times now you're beginning to derate when you get to this point. So what is the impact on the fouling? Well, you got that poor heat transfer. Remember, we've got that risk anyway, a little lower heat transfer to begin with. Now we've got this poor heat transfer coming up because you have fouling and the air cannot get through the fins themselves. This drives operating costs higher. So now on most of these larger fans, you have some sort of variable frequency drive that will increase the speed of the unit or decrease based upon pressure. And that pressure, as it begins to increase, causes that fan drive to increase the speed of the motor itself. And so the fans begin to turn a little faster. What happens now is that you're trying to push that air, force that air up through the system itself, and you're getting a higher pressure, and you're not getting much more results. But you are putting more pressure on the fans. You're putting more pressure on the mechanical equipment. Now you're risking the fact that maybe you're going to have some oil start to leak, and you're going to have to do more maintenance on that particular unit, and you're going to increase the amount of power you need on those fans to get that air up through those fins. Also, you have a deterioration of turbine back pressure, and that leads to a restricted megawatt output. So maintaining efficiency is really key, and the easiest method of maintaining peak performance is to make sure that those tubes are clear of all debris and that the air going through those tubes meets minimum resistance so that you can use that surface area in order to get an efficient unit. Now, on a vacuum steam system, a 20% reduction in airflow will increase turbine pressure by around 33%. Now, that will vary based on your particular application, but these can give you some ideas of what we're talking about in terms of money. Now, in the past, we've run into a variety, and we still run into these quite often. 3 basic methods that people use to try to clean their unit. One is the fire hose, one is a high pressure hand lance, and the third is the automated cleaning. So let's go a little bit now and just take a look at them. And what does a fire hose give you? Well, you can imagine you're trying to drag that fire hose up those steps, or trying to lift it up. And now you've got to work your way up onto the fins themselves. So you've got to erect some scaffolding. As soon as you put scaffolding up there, now you've created a situation where there's a risk, there's a possible safety problem. And so you've got to take a lot of time to make sure that the people that are doing the work are very safe. You don't want somebody to fall. So that slows the process down. The fire hose itself has a very high volume, but it's got a very low washing effect because it's got a very minimal pressure. So what happens is the water, or the fins closest to that water, or that hose, do get the weight of the water and the pressure that is available coming out of that hose directly, and you are able to remove all the loose debris, and maybe you can actually push some of the debris in the fins out. But in many instances, what happens is you just drive the debris from the top level down into the lower levels of the fins, into the second and the third layer of fins, and you begin to cause more problems because you're compacting that now. So in the end, you get small improvements since only a portion of the debris is removed, and you get a lot of compacting of that debris down into the fins themselves, which could cause bigger problems for you. Now, a high pressure hand lance, one of the advantages is the pressure. It's a low water consumption and a high pressure. So as long as you get the angle right, the person that's standing up there has the angle right, you're able to keep that pressure going parallel to the fins, and that will drive out all the debris between them. But as soon as you begin to move that wand back and forth, you change the angle. And once you change the angle, you defeat the ability of that hand lance to remove the debris. In fact, once that angle changes to a certain portion, you then begin to impact the fins themselves, and that angle can bend the fins, or you can take the galvanized coating off the fins themselves, so you can damage that surface. So you've got to be very careful when using a high pressure hand lance. Again, you've got to put up scaffolding. That raises the safety issue again. And in the end, when you're all said and done, because it's manual and somebody's got to be able to do this, you're going to have small improvements because you're only going to get a portion of the debris out, and you're going to end up with damaged fins in the long run. So now you have the automated machine. And the basic idea of the automated cleaning machine is that you get a significant water volume, much like the fire hose, but you get an increased pressure, like the high pressure hand lance. The huge advantage is that the nozzles that are on this particular unit are able to be adjusted so that the angle is consistent at all times. So at no time does that angle impact the fins themselves. We're able to keep that parallel. You can also raise and lower the nozzles themselves to meet the dimensions of your particular unit. You get a consistent and solid pressure driving the fouling out between the fins and down in through the unit so that you get a complete cleaning. The carriage moves at a constant speed, so that means that the entire unit gets cleaned evenly. There's no need to shut down the entire unit, shut down a fan, and there's no need to erect scaffolding. So once the unit is set in place on that particular side, we have a much safer operation for the people that are running the unit itself. And in the end, you remove the fouling effectively and uniformly across the entire unit itself, which is really what you're looking for. And this is just a picture. I'm going to show you a few pictures here now. This one just shows you what the rig looks like. And you can see the carriage rides up and down that spine, and you can see the nozzles. In this case, there are 12 of them. Those angles are all set ahead of time so that the angle that's coming out of those nozzles corresponds to your particular unit. The pressure of the water is driving down through those fins, and the carriage drives up and down or rides up and down that spine so that you get an even and consistent cleaning. This is just another picture of the same thing. You can see how the spine goes from the top up where the steam header to the bottom, and the unit itself rides up and down that unit automatically so that you get a very good operation. Now, how do you know if you're getting a good cleaning? That's one of the questions we were always asked. How do we know? How do we know if we need a second pass, or sometimes if it's so bad, a third pass? Well, one of the things that you do is you go down inside the unit itself while the cleaning is going on. And you can see on this picture that the pressure of the water is still pretty significant as it comes through that unit. And when it comes out with this kind of pressure, you know that you've got enough pressure remaining coming through that unit that you've cleaned all those tubes. You're getting a good solid cleaning because the pressure's coming out on the other end. If you were here and you saw that dribbling out of the side, or the pressure's only coming out a half inch to an inch, you would be pretty solid to think that you need, pretty consistent to tell yourself you need another pass in order to get it as clean as you want to get it. So this is a way to get in there, take a look with the cleaning itself, how it is cleaning, and what kind of results you can expect. Of course, once this is done, you can always get down and take a look, and you should be able to see up through those fins up into the sky, and that tells you got a good cleaning. Now here's the basic setup. And so when you go in to set the unit up, one time per wall, the technicians go in, they bring the unit up. It can be mounted from the top if you have a rail, or from the bottom. Once that is set up, they come off those ladders and the unit is ready to go. But this gives you an idea of what that looks like up on your ACC unit. The unit can also be set up if you have a fin-fan unit, or if you have a horizontal cooler of some sort. So the unit can be set up on those types of coolers as well in order to get the same type of cleaning. Sometimes you got to run into situations where the fan housing itself is too low, and you've got to work around that. But that is something on a case-by-case basis that you've got to take a look at. In the end, what you're looking for are clean tubes. And if you remember the picture I showed you before on the left, the fouled fins of that particular unit, you can see it's the same picture. That's what we've got. During the cleaning itself, you can see the pressure coming through. And notice the contrast. On the left side, the upper left side above the water, you can see how it's clean. Whereas on the right side of that picture, you can see that the unit hasn't been there yet, and that's still fouled. So you can see right there the contrast of how the unit is working, how it's able to clean and drive all that debris out. And in the end, of course, you want a clean unit so that you have free airflow through that system to give you the highest efficiency possible. What this does is gives you an immediate performance improvement. So when you're done with the system itself, when you're done with the cleaning, and you start that fan back up, you should see an improvement right away. It allows the fan speeds to be reduced because they're not running into a higher pressure. The fans, or the air itself, is able to go up and freely move through those fins. You also get, because of the utilizing all the space and all that fin all the fin capacity, you're able to get a much more efficient and effective condensing using this particular type of application. And in some instances, you can see an increased generation capacity as a result of the cleaning itself. We have seen them as high as 15 to 18 megawatts, sometimes a little higher. Economic savings, you can just work it out, but we had one plant in the UK a while back that actually was saving 18,000 a week. But you can sit down and figure out what it is means to you in terms of the fan speed, the amount of draw that you're bringing in, and also how much you can make on the extra megawatts that you're able to sell. So in conclusion to the cleaning side of this presentation, air-cooled condensers are very viable. And like I said at the beginning, we are seeing more and more air-cooled condensers every year. Every time we go to the ACC users group, there are new people that have condensers and they want to learn about the upkeep of that condenser and one of it being cleaning. We also have people there that are sitting in and listening because they know they're going to be getting one soon. So we see more of them all the time, and they are definitely a viable alternative. They allow this plant to be built wherever without any issues with water. But because of the fouling tendencies of air-cooled condensers and because of some of the inefficiencies of air itself and some of the problems that you have as far as summer temperatures, it is imperative that the air-cooled condenser be cleaned and effective so that the flow of air is able to get through all those fins and you can utilize those fins extensively to give you the performance improvement that you need. So now we run into the next portion of the presentation, and that is leak detection. And this was something that years ago when I went out on my first ACC unit, and I'm going to probably tell you it was 18, 19 years ago. You take a look at these large units and you think, how are we ever going to be able to find a leak up on them? So we are going to go into the indicators and the impact on the system, the equipment used, and challenges that we face on an ACC unit as part of the presentation right here. Why test? Well, because if you have a leak and every unit leaks, I don't care what type of condenser you have, I don't care what type of power plant you have, there is air in leakage in that unit itself. The question is, when is the amount of air in leakage overcome the unit's ability or the air removal system in the unit to remove all that air? And thus it becomes a real problem because now it is impacting your particular unit and back to how many megawatts you can generate. So we say, hey, why don't you take a look at a routine inspection? Why a routine inspection? Because like I said, you know you have air and leakage. When you go into an outage, if you go in and do a leak detection right away, you can find that small leak that you didn't know you had because your air removal system is capable of removing that air. But you don't know how bad it's going to be in July. So if you go into that outage and you know what you've got to fix, you can do that leak, find it, and repair it. On the other side, when you come out of these outages, after you've changed gaskets and changed valves and you've gone in and you removed bolts and you torqued them back up, maybe it'd be a good idea to also do a test right then, or maybe do the test then to make sure that everything you've done is buttoned up tight. Because if not, it's going to raise its ugly head when you start that unit up and start pressing hard. And sometimes it'll show up right away. And trust me, when it does, that's the best time because you are not under the gun to give them all the megawatts you need. The time that's worse is when you're in the middle of the summer, you're trying to pump out all your megawatts. You can't do it because there's a leak somewhere in the system. And that's when we get to the bottom one there, the emergency inspection. And this is what we typically get, a telephone call saying, we have a leak, got a problem, and we need your team out there now to find the problem so that we can get our unit back up and running efficiently. Helium is the gas that we use. Helium is quick, it's reliable, non-toxic, non-hazardous, so no EPA issues. It's an accepted form of tracer gas used throughout the industry. It's very sensitive. Detection range is 1 part per 10 million. So it can find most every leak that you're going to have. So that is the gas that is used in order to find the leak itself. Now, what kind of challenges do we have? Well, the basic setup of the equipment is the same in an ACC as it is for a steam surface condenser. But like I said before, these ACC units are quite large. And so shooting at the tracer gas can get tricky because some of these elevations are 50 to 75 feet in the air. Some are higher than that. So you've got to be able to be a little bit innovative in order to find the leak on one of these units. ACC units, very large volume of stairs, individual streets to navigate. So staging of gas cylinders is critical in order to save time. So the big play here is experience. One of the biggest things for you as a owner of an ACC unit is to know that the team that you call out has experience to do the job, because an experienced technician can save you not only hours, but possibly days to finding that particular unit or finding a particular leak on that unit. Now, how easy is the setup? Really quite easy. We can actually set this analyzer up in the back of a car, drive the car up to the unit itself, pull it right next to the ACC, pull it under the ACC, whatever, and set up the analyzer right there. We can set it up on the deck if needed. So it's an easy application to set up the analyzer. What's required once we've got the unit on site? So we're set up and ready to go. Well, we need steam flow. And this is for, I don't care what kind of condenser, steam or an ACC unit. What you're trying to do here is you're trying to make the helium move throughout the system. You want to drive it from your entry point throughout the system so you find the leak. Otherwise, what happens is the helium just finds pockets, and that pocket of helium will just sit in that location. Eventually, it will leak somewhere, and you'll get a false leak, but you'll never really find the proper leak. So you want to have about a 15% flow going. That pushes that helium down through the system. That clears the tracer gas out so you don't get any false responses. You get a quicker response time. Your analyzer's quicker, and you're able to find the leak quicker. So you need some power in order to drive that steam flow down through the unit. And this is what a typical response looks like. So the analyst who's sitting down by the equipment itself and the technician up on the unit, they have a gas release, and that gas release is now going through the system until it hits that initial response. Once it hits that initial response, that's when the technician or the analyst says, hold on a second, we have a hit. Now we're going to take a look at the rate of response. We're going to take a look at the magnitude of the response, because that gives us an idea of how big and to what depth that leak is. We'll know a lot from that leak itself by analyzing that. As the steam flows and pushes the helium gas down the line, we get a clear out time until we come back to the baseline. Once we come back to the baseline, we can then retrace steps in order to pinpoint the leak. And of course, with the printer, we're able to keep all this data so that we have a record of where it is and what we're doing. So now we're out on this unit, and the big question we get a lot of times, and even I have it, is where do you start? You're looking at this large ACC. Maybe you have 2 streets. Maybe you have 7 streets. Where do we start such a large unit? Well, first thing is you've got to have an experienced technician. Experienced technician is going to come in, and he's going to start asking you questions. And as he asks you questions, that's going to pinpoint to him some ideas on where to begin. But we find in a lot of instances that the air and leakage is actually found below the fan deck. And so, good place to start, to look below the fan deck to make sure that the leak is picked up there rather than go up on top of the fans themselves. We run into a lot of instances where the indication is that the leak is up on the street when in actuality it isn't. It's down on the ground level components. So again, an experienced technician, he can save you a lot of time and a lot of money in finding that leak. So the methodology when we get up onto these units themselves is to get up on the unit, and we use extensions to the shooting probe. We use some ladders. Sometimes scaffolding has to be erected for this because of where we've got to go. But we do have some tools that allow us to reach high up onto that ACC unit so that we can pick the leak up anywhere in that particular bundle. We use thermal guns at times. What that does is that gives us a good idea. If the leak is big enough, it gives us a good idea in the general direction of where the leak is, and then we can get up there with the helium. And in some instances, if available, if we're able to shut down a fan room, we can do a gross shot of helium into a fan room to get an idea, are there any leaks in this particular case? So there's a couple different tools that we use. This, again, comes with experience. Run into a lot of Hogger issues. Now, on an ACC unit, the Hogger and the air injectors are outside, so they're sitting out there in the elements. They can be subjected to a wide range of temperatures, pressures, snow, whatever. And for that, they run into a lot of issues with the Hogger itself and the Hogger valve. And what happens is over time, that seat becomes bad and doesn't sit properly. And so you get the leak in through the Hogger system. And that is enough to overwhelm the air removal. And so you can get that leak. So that's a place that we look at quite often, and the place that you should know is a viable leak. Where else? Well, cracking of the tube welds. Anytime you have a weld on the unit itself, and you can imagine, if you think about it, these large units out there in Mother Nature, going from the wide temperatures, having winds gust up, the units themselves can go through a lot of contraction and expansion, the metal. And so what happens is these weld ports, the cracking of tube welds at the apex and the base can occur. And so those are common to find leak in those particular areas. Bundle weld leaks, wherever the bundles are welded together, those are common places. And the exhaust duct and the bellows high up on the unit itself, because they're exposed to the weather the most. Now, just going to show you some pictures here of what we do or what's used in the industry. This is where one of the technicians is using the extension. You can see that extension can go all the way to the top. It can be extended up with different pieces to add on, so we can get from the floor or the base of that unit all the way to the top without any scaffolding in this instance, although in some instances you will see scaffolding would be required. Here's a bypass leak. This is one that we found. And in this instance, what it does is when we find these type of leaks, instead of you having to take apart all the insulation, we can find the leak with the insulation on and then narrow down so all you have to do is remove a smaller portion. This reduces the amount of time and effort your people have to play in getting the insulation off and in repairing, re-insulating that pipe. But in this case, we found an 18-inch crack, opened this up, crack was repaired, insulation put back on, unit was back up and running. This is the Hogger, and you can see in this instance, as I was trying to explain before, there it sits at the base of the unit itself, exposed to all types of debris. And so we have issues right here. So this Hogger valve can have problems. Either side of the tube, bundle weld. At the bottom there, as we go down, you can see the weld in the middle. As we put those together, or as they are put together, that welding point becomes a weak point in that particular piece of equipment. And so right where they are welded is an ideal place over time to find a leak. And we run into this quite often. We find a leak, the plant goes in and repairs it. Not commenting, the repair's fine. They cut away the fins. They use some material to seal that up so that they don't have that problem. But if you look at the one tube, right at the end of the red material, you'll see that the tube is cracked. Because what has happened here is you have replaced the stress from the end of the unit where it's butting up against the weld points up to where the tubing is itself. So you've just moved that stress point up. And now over time, between the steam line going down, steam and the heat and the cooling of the air itself, that takes a lot of pressure in with cracks. So anytime we're out looking at a unit, we take a look at where things have been repaired and we inspect that area, because in many cases, there's going to be another leak. Base weld leaks, again, these are pressure points, a lot of pressure on these particular corners, and so leaks develop there as well. Directly onto an exhaust weld. Again, this piece of equipment, large piece of equipment, exposed, very susceptible to the wind, very susceptible to the temperature range, and you can get cracks pretty easily. You can imagine the vibration of that unit up there at times whenever the winds get high, and so those weld points are key also. Exhaust bellows leak, of course, it's out away from the ACC, more difficult to get to, but this is an area that we've got to get up and take a look at. And so in many instances, the exhaust bellows is an area that leaks. And vertical rupture discs. Now, some plants don't have vertical. Some of them have horizontal. And the ones that have horizontal, we find less leaks on the horizontal rupture discs, but the vertical ones tend to leak more. They're up top of the unit itself. There's probably some physics in there as to why, but a lot of times you'll get a leak. These are difficult to get to in many instances. Tough to find your way up. To get up to that unit, you have to have some sort of scaffolding. But when we see it there and we know that you have a leak and the discussion lends itself, this is an area that we will have our crews go up and take a look at. Many times we will find it there. Now, been talking about the weather, and boy, the weather really plays a role, because we have found that geographies play a big part in the leaking of ACC units. And what we have found is that those areas in the northwest, northeast, really most areas that have vast weather changes, they end up having a leak, and we find the leak in the same area. So to pick a location, if we're up into the Montanas or the Wyomings of the world, they're going to get that temperature range where it's 110 in the summer, and in the winter it's going to be minus 30. That's a heck of a temperature range that unit's got to face. And on top of that, as the wind comes down over Canada and comes down into those states, there's really not much there to stop it. And so the wind comes down and batters these units with the cold air and with higher pressures of air itself. And we find that where the wind is coming from, that direction is the area that you get the most leaks. And when we find a unit that has a leak, that's in an area where you get that type of swing, the next time you have a leak, we go back to that same area, because many instances we see that the leak is prone to that particular part of the unit itself. So the big point we want to bring about here when you do leak detection, and these were only some of the areas that you can find leaks. You can find leaks anywhere along that system. You can trace them all the way back to the power plant itself. You can find it on the ground level. You can get up onto the A-frame, up at the top of the A-frame, on any side. So you've got to be able to transverse this entire unit and do it effectively and efficiently. And the only way to do that is experience. So when you're looking for someone to come out to do a leak test, you want to make sure that you have experienced technicians. They will save you time. They will save you money. They will be able to find the leak quickly. There's been many an instance where crews have been out there that do not have a lot of experience, walk away without finding the proper leak. They find a leak, but not the proper leak. And bring the unit back up, and you still have a leak, and you still have a problem. So it's key to make sure that you have an experienced crew, because they are the ones that are going to be able to come in, talk to your team, and through their experience, be able to find the leak that is on your unit. And once that leak is resolved and you clean that unit and keep it clean, you can have an ACC unit that is running very, very effectively and very efficiently, have a tremendous operation there. So with that said, I have completed my portion of this presentation, and we are open to questions. So if there are any out there, feel free.
Thanks, Gary. We've got quite a few questions that came in via the chat, and we'll go through those one by one. Alternatively, you can keep submitting those questions in, or you can use the raise hand feature. If you just hover over your name, you can click on the little hand and we'll call on you as soon as we're ready. So Gary, I guess we'll start off with some cleaning questions first. How do you deal with ACCs with installed louvers?
Okay, some of the louvers themselves, we'd have to remove them, or in some instances, we can get under them. It depends on your particular unit, whether we can get the cleaning system underneath the louvers. We have seen ACC systems that have louvers just on the upper portion of the ACC itself, and we have extension rods that can get under those louvers, but there have been instances, we have seen units where the louvers are so tight to the unit itself that we'd have to come up with another type of setup to get around the louver, open the louver up in order to go over the louver, which would reduce the effectiveness of the cleaning, or actually remove it. So they can be a problem, but it would be one where I would recommend that you contact the company you want out there and have them come out and do a site visit, taking a look at it, and then the two of you can work out how you want to handle that particular application.
All right. Would you expect efficiency improvement even when there's no visible fouling, but the unit hasn't been cleaned for, say, more than 10 years?
Oh, absolutely. Absolutely. 10 years is a long time. I mean, no matter where you are, you're going to have something blowing around in that air, dust, dirt, pollen, and it's going to get up in between those louvers, or in between those fins. I'm thinking louvers now, in between those fins. And sometimes it won't plug the fins. So you can bend down and take a look and see the air through them. You'll still have a passageway, but you may have this fouling coated on the fins, so you've reduced the ability to transfer heat. And so that heat transfer will affect your overall operation. So 10 years is a long time. I'll say that in most cases that we deal with, we get our people asking us to come out every year, sometimes every other year, but over a 10-year period, unless you've somehow got in a clean room or something, you're going to have debris in there. So yeah, you should see improvement.
Okay, there's quite a few questions about the water quality. What kind of water should be used during the cleaning, and are there any kind of chemical aids that can be used besides just water? So can you just speak to that a little bit, please?
Sure, no problem. No, we use whatever water you have. Fireline water is great. A lot of ACCs today have water lines that are already piped in up to the top, and we use whatever water is available. Remember, this pressure in this water is being driven through pretty quickly with a lot of force. So we're not going to have any of the particles or particulates that are in this water played out on the fins themselves. That's not going to be an issue. Can we add an additive? We can, we don't. We almost always use plain water unless you have a situation where maybe oil. Maybe you have an oil leak on one of the fans, on one of the drives that you have, and that oil has splattered up into the fins. Then we can get a biodegradable degreaser. We spray it on, we leave it on for a while, let it soak in, and then we run the unit over that. And we can do that as many times as needed. Sometimes it's more of a pick and a poke. You put it on, you clean it, you see how well it cleaned. And if you have to do the degreaser, then you will. But we typically just get away with water. But there are instances, yes, where we can get a biodegradable degreaser.
Okay, is there a minimum ambient temperature, to actually have a cleaning?
Wow, that's a really good question. We ran into a situation this year where we did a cleaning in April. And it just so happened that the nights got uncharacteristically cool. And the temperatures got down into, say, the 40s. And even though I know that's not freezing, that caused problems. That caused problems with the cleaning. So we don't have anything recommended, but I would say you'd want to try to probably hope that it stays above 50 degrees. We do most of the cleanings in the United States, at least. We do most of our cleanings in mid-April through the end of September. We do them outside that sometimes, depending on where you're located. People in the Southwest can get away with it, but I would say that ambient temperatures above 50 would probably be recommended. It gets awful cold up on top of those units also, so you've got to be cognizant of that.
Okay, there's a couple of questions about the, using a biodegradable or degreaser. Do you have any recommendations for a suitable degreaser?
I can get that for whoever wants it. That would probably be, I don't have it off the top of my head, but certainly I can get those. We do go buy them. A lot of times the plant buys them. They say that, they know what their requirements are for their EPA standards, but I can get it. So if whoever was interested in that, let me know and I can give you some suggestions.
Okay. Have you ever witnessed any units that have been damaged by dry ice blasting or nanoparticulate cleaning?
I have not. Personally, I have not. I don't know if any of our technicians have. I don't know if our leak detection guys have. That would be an excellent question asked at the ACC users group, to be honest, but I haven't seen it.
All right, and then just one more, based on performance, what can cause performance reduction other than clogging of the fins?
Well, you could have blockage in the fins. You could have we've had seen ACCs where the tubes themselves up in the steam header have become so degraded that there were leaks up there and you weren't getting the proper pressure going down the unit itself. You can have condensate problems at the bottom of the unit. Just about anything on the mechanical side that you would have in a steam surface condenser. If you have any of the heat exchangers or anything go bad, you can have pressures and problems there. But cleaning is probably number one. File them, that's number one. And the second would be air and leakage. That would be number two. But there are other things that can happen mechanically that just don't allow the unit to run properly. You could have fan issues. You could have issues with I know there was one during the ACC users group where there was a big discussion about wind blowing, actually getting gusts of wind that blew across the fans, underneath the fans, and robbed the fans of air. So you weren't getting enough air up through it. Get enough air up through there, then that's going to be a problem also. So there's a lot of things on an ACC that can go wrong. Again, anybody that has one, I would strongly recommend the users group because these guys have been running these fans and these ACC units for years and years and years, and they've learned a lot just by experience.
All right, another quick question came in. Can you install an ACC cleaning system on a unit after construction, I suppose?
Yes. Yeah, if you wanted your own unit, your own cleaning system, you can purchase it. For a plug-in for us, we can get it for you. We can install it for you. The advantage, of course, is then you have the unit. And theoretically, you could do the cleaning yourself. The negative to that is you own the unit. You've got to now maintain the unit. And the guy that's running the unit does it once a year or something like that. You hope he doesn't leave because then you've got a unit that you don't use. But we have quite a few systems out there where the plant has bought the unit, put on the rails, bought the control system, bought the carriage, and then they talk to us about coming out, making sure it's operational, getting it up on the system, cleaning the unit, bringing it back down.
All right, I guess now is about the time we'll move into questions on leak detection.
Okay.
First question is, can you give a recommended interval for performing leak detection?
Well, leak detection is really difficult as far as an interval. If it was me and I had an ACC unit, there's no doubt that I would do a leak detection at least once a year after my outage to make sure that everything I did is not a problem. I would do that just to make sure that the unit's up and running. The last thing you want to have happen is for that unit to have a problem in July or August or when you're pushing it. But typically leaks, you know, they come around, and like I said, every unit has leaks, and sometimes it's a very small leak that is just ready to go. And when you push that unit, it happens. So I would recommend at least once a year to do a leak detection. Sometimes you got to do more than that, though.
Okay, would an increase in oxygen level indicate a potential leak?
Yeah, it could. You know, from the chemistry side, and I'm not a chemist. I'm going to be right up front. I'm not a chemist, so that's got a tougher question for me. But yeah, if you have an increased oxygen level down in the condensate area, you can suspect that that could be the reason. But there's other reasons of which I'm not completely aware, but I know that I've talked to people who are chemists who tell me some of the issues they run into. That an O2 issue could be caused by some other event, but it's certainly viable if you think you have a leak and you see an O2 increase to do a test. I mean, a leak test is not terribly expensive unless you have a extremely large ACC.
Okay, we do have Barry Dooley and David Addison, two chemists on the line. Again, Barry, if you could, or David, if you can provide a little bit of insight on the oxygen level, that would be great.
Yeah, Scott, the answer is somebody already answered it. There's definitely a relationship, and you know, we normally look for condensate pump discharge oxygen levels less than 20 on units that have ACC, and if there is an air in leakage, and you would expect it to be larger than that. There's definitely a relationship, Gary, and Scott, while I'm on, I'll just answer a couple of other things. There is an IAPS technical guidance document on air in leakage, which includes all the locations that Gary included. It also includes a little bit of the science of air in leakage. And there was a question about how to perform a vacuum decay test. If you get that IAPS document, you'll be able to see all the science and the actual process itself in that document. And I just sent to Scott a copy of it, and we usually put those on a website, and Scott will provide that for you. And the final comment, Scott, was that there is an ACC users group. I chair the chemistry and corrosion section. It meets in October. Somebody asked how they find out about it. You can go to the ACC user group website, and you can register for the meeting. It's open. It's basically open to anybody, and I'm sure Scott can provide that detail as well. There it is. Thank you.
Okay, Gary, there's just basically just two more questions. One is on acoustic leak detection, if you've heard of any success stories or maybe even drawbacks of using that.
I have no experience whatsoever on the acoustic side. I know that they've used the acoustics in steam surface condensers on other pieces of equipment, but I have no experience of the acoustic being used on ACC. So I'm sorry about that, but I can't answer that one at all.
Okay. And then just quickly, do you have representation in Europe and in Colombia?
We have representation in Europe. We have an international group here, and that gentleman is the one who is in charge of all the offices that we have around the country. I do not know if we have an individual in Colombia, but if there's interest there, certainly send your information in. We'll get you in touch with the international sales manager, and he will gladly talk to you about our representation. But we do have offices throughout Europe and down into Australia, and do cleaning in all those areas.
All right, well, that's going to bring us to the end of the hour, and it doesn't seem like there's any more questions left in the queue. If there are some questions that we missed, I'll be sending them along to Gary, and he'll be able to answer you in an email. And just a quick reminder that we are having the virtual conference for the ACC Users Group, October 12th to 14th. And you can just go to the acc-usersgroup.org to register. And we certainly look forward to your participation, and we thank everyone, especially Gary, for taking the time today to walk us through ACC cleaning and leak detection. Thanks so much, Gary.
You're welcome. Thank you all for all your time.